In this video, we'll talk about solving inequalities when the given functions are already in the factor form. Let's dive in some examples now. Solve this inequality x times x plus 1 greater than or equal 0. So the first step you need to do is you need to solve the equation x times x plus 1 equals 0. This is actually a product of two functions, x and x plus 1. The product is 0, equivalent to either the first function equals 0 or the second function equals 0. We have x equals 0 or x plus 1 equals 0. For x plus 1 equals 0, we can subtract both sides by 1 to isolate the x. So the left hand side we only have x and the right hand side 0 minus 1, we have minus 1. So the solution for this equation is x equals 0 or x equals negative 1. This is the first step. Second step, you need to draw a number line, which is this one. Then on the number line, you pin down 2 points, which is two solutions we just found above, minus 1 and 0 right here. This is the second step. The third step, we choose a simple number on this number line. This number must not be the solutions above, which are minus 1 or 0. For example, we choose 1. Then we plug number 1 to the original function and see, for example, we put 1 times 1 plus 1 equal 1 times 2 equal 2. And this is a positive number greater than 0. Because the value of 1 make the original function positive, we draw a positive sign right above number 1 right here. Pay attention here. In this number line, there are only 2 points that make the original function equal 0, which is minus 1 and 0. All the other points will make the original function either positive or negative. So we found out at a value of 1 that make the original function positive. So we draw like this. When it's hit 0, then you put it down. Then from negative 1, you draw it up. What does it mean? It means all the variables greater than 0 will make the original function greater than 0. All the variables less than negative 1 will make the original function also greater than 0. And all the variables less than 0 and greater than minus 1 will make the original function less than 0. Why? Because anytime that original function hit the solution, it will change its sign. Because we found out from this branch it's positive. So when it hit 0, which is the solution, that make the original function equal 0. And then when it go below that, it change from positive to negative. When it hit a solution again, which is negative 1, it make the original function equal 0. And then it change the sign from negative to positive. Based on the diagram you draw here, you can see when x greater than or equal 0 or x less than or equal negative 1, we see the original function is positive or equal 0. But when x less than 0 and greater than negative 1, we see the original function will take the negative value. Therefore, we can write the solution for this inequality as x greater than or equal 0 or x less than or equal negative 1. We can also graph the solution set in the number line like this. We draw a number line, then we put negative 1 right here, 0 here, and the solution would be x greater than or equal 0. We have the bracket here. This means we choose the solution as 0 also. And then x less than or equal negative 1. We have this bracket here. The solution from here to positive infinity and from negative infinity to negative 1. Anything in between, minus 1 to 0, we don't take it. Please keep in mind we also take negative 1 and 0 as two solutions. Let's work on the next example. We have to solve x minus 1 times x plus 2 less than 0. So the first step, we need to solve this equation. X minus 1 times x plus 2 equals 0. We can see this is the product of two expressions. So this equation equivalent to x minus 1 equals 0 or x plus 2 equals 0. For x minus 1 equals 0, we can add both sides by 1. So the left hand side is x and the right hand side is 1. So x equals 1 is the solution. For x plus 2 equals 0, we subtract both sides by 2 in order to isolate the x. So the left hand side is x and the right hand side is 0 minus 2 is minus 2. So x equal minus 2 is another solution for this equation. I write down two solutions here. X equal minus 2 or x equal 1 right here. The second step is we try to draw a number line. Then we pin down two solutions here, which is minus 2 here and 1 here. Then the next step, we choose a simple number on the number line, but that number must not be the solution of this equation. For example, I choose 0, right? 0 is between minus 2 and 1. 0 is a simple number. So I put 0 here. Then we substitute x equals 0 back to original expression. X minus 1 times x plus 2. We have 0 minus 1 times 0 plus 2 equal minus 1 times 2 equal negative 2. And this expression is less than 0 when x equals 0. So we see the original expression will have the negative value when x less than 1 and greater than negative 2. Because you see 0 is between minus 2 and 1. So from here we can draw like this. From here we draw when the original expression hit 1, which is the solution, right? It will change the sign after that. And then from here, when it hit minus 2, you can see the value of this expression is 0. But when it passes minus 2, it's become positive right here. And then from positive right here, the function goes to 0 at minus 2 right here. And then it goes to negative number. Then the function goes to 0 value right here at 1. And then it goes to positive value right here. Based on the diagram we just draw here, we can see the original function less than 0 when x less than 1 and greater than minus 2. So we can write the solution as x less than 1 and greater than minus 2. And we also can draw the solution set on the number line like this. We put minus 2 and 1 here, right? Then we use this bracket. This bracket means the inequality don't take number 1 as a solution. We put this bracket as x greater than minus 2. This bracket means less than 1. So anything that on the right side of number 1, we eliminate. And then anything that less than minus 2, we don't take these values. The solution is between from minus 2 to 1 here. Let's work on the next question. We have x times x minus 1 times x plus 4 greater than or equal 0. We need to solve this inequality. The first step we need to do is we need to solve this equation. X times x minus 1 times x plus 4 equals 0. Similar to previous example, this equivalent to x equals 0 or x minus 1 equals 0 or x plus 4 equals 0. For x minus 1 equals 0, we can add both sides by 1. So the left hand side is x and the right hand side is 1. So x equals 1. For x plus 4 equals 0, we can subtract both sides by 4. So the left hand side is x and the right hand side is 0 minus 4 is minus 4. This equation has 3 solutions: minus 4, x equals 0, or x equals 1. This is the first step we need to do. The second step we need to do is we need to draw a number line. Then we pin out 3 solutions in here: minus 4 right here, 0, and 1. This is the second step. The next step we need to do is we need to choose a symbol number in this number line, and then we put it in original expression and evaluate the value of that expression. For example, let's say x equals 2. We put x equals 2 into the original expression: 2 times 2 minus 1 times 2 plus 4. So you have 2 times 2 minus 1 is 1. 2 plus 4 is 6, and then this value is positive. Let me draw number 2 here. Keep in mind 2 is not solution. The value of 2 make the original expression positive. You draw a positive right here. Then the next step, what we are going to do is we draw like this. From positive, we draw a line. When it hit the first solution is 1, right? That make the expression equal 0. So you draw like this. Then when it passes number 1, it goes to negative value. Then it hits 0, the original function will take the value 0. Then when it passes 0, you have the positive value for that function. Continue withdraw, right? When it hits minus 4, the function goes to 0 again. When it passes this solution, it goes to negative value. Based on this diagram, you can see that the given function greater than or equals 0 when x greater than or equal 1 right here, or x greater than or equal negative 4 and less than or equal 0 from here and here. So I can draw the solution set like this: x greater than or equal 1 right here. Let's make the function positive or equal 0 right here. Or x greater than minus 4 but less than or equal 0, because when x equals minus 4, the function equals 0, and x equals 0, the given function equals 0, and x take the value in between, the given function is positive. So this is the answer for this question. You can also graph the solution set in the number line like this: minus 4 right here, 0 and 1. X greater than or equal 1, you draw like this. You use this bracket. This means you include the number 1 right here, and then anything that greater than 1 right here. Or x greater than or equal negative 4, you use this bracket. And x less than or equal 0, you use this one. So anything that greater than or equal negative 4 and less than or equal 0, we take these value, and then we don't take this range and this range. Here is another example. We need to solve this inequality. The first step we need to do is we need to solve this equation: x times x plus 2 times x minus 3 times x minus 5 equals 0. Similar to previous problem, this equivalent to x equals 0, or x plus 2 equals 0, or x minus 3 equals 0, or x minus 5 equals 0. For x plus 2 equals 0, we subtract both sides by 2. We have x equal minus 2. For x minus 3 equals 0, we add both sides by 3 to isolate the x. Then the left hand side we have x and the right hand side is 3. For x minus 5 equals 0, we add both sides by 5. So the left hand side is x and the right hand side is 5. So this equation have 4 solutions. X equal minus 2, 0, 3, and 5. This is the first step you need to follow. And then the second step, you need to draw a number line. On this number line, you put these 4 solutions. Minus 2 right here, 0 right here, 3 right here, and 5 here. The next step, you choose a simple number. For example, I choose number 6 because you see, number 6 is very simple because 6 minus 5 is 1, and then you can easily find the other terms. We substitute 6 into the original function. We have 6 times 6 plus 2 times 6 minus 3 times 6 minus 5. 6 minus 5 is 1, 6 minus 3 is 3, 6 plus 2 is 8, and then 6 right here. The result we don't care because they're all positive numbers and the result must be positive. It means you can draw like this. You put number 6 right here. And keep in mind 6 is not the solution. And 6 make the original expression positive. You draw like this. Then from positive infinity, when the function hits the first solution is 5, the function will hit 0. Then when it passes 5, the function will go to negative. Then when it hits 3 again, then the function hits 0. Then it passes 3, the function will have positive value. Then it hits 0 again, the function will hit 0. Then when it passes 0, the function will have negative value. When x hits minus 2, the function will have 0 value. Then when it passes minus 2, the function will have positive value. Based on the diagram we just draw here, we can see when the function less than 0 is when x on this range minus 2 to 0 and 3 to 5. Or the solution is x less than 0 but greater than minus 2, or x less than 5 but greater than 3. This is the solution. You can also draw the solution set on the number line like this. You put number 2 right here, number 0, number 3, and number 5 as 4 solutions of this equation. Second step, you see this diagram, right? You see this is positive range. You don't take it. From 3 to 5, the function is negative. You take it. And you see this is the less than sign, which means we don't include the equal sign. So we use this bracket. And then from minus 2 to 0, the given function is negative. We draw like this. Then anything in between, we don't take it. We don't take this value. We don't take this value. Even for solution right here, we don't take these 4 values. We just take the values in between from minus 2 to 0 and from 3 to 5. And this is the solution for this question. We noticed that all the problem before that I gave you, the original function has different solution. But what if the original expression have the same solution? For example, x to the third less than 0. So the first step we need to do is we need to solve x to the third equals 0. In this case, you can rewrite this as x times x times x equals 0, right? You can see this equation equals 0 when each factor equals 0, which means x equals 0 or x equals 0 or x equals 0. Basically, this one you can write it as x equals 0 or x equals 0 or x equals 0. Why I write this 3 times, I will explain soon. The second step, you need to draw a number line again. In this case, you imagine we have 3 different solutions. You draw 0 right here, right? And then you draw another 0 right here. And then you draw another 0 right here. Next, you choose a number that is not a solution, which is 0 right here. For example, I choose, let's say 1, x equal 1. Then you substitute back to the original function, which is x to the third. So 1 to the third equal 1, and it's positive. So you can draw 1 right here. Remember, 1 is not the solution. The value of 1 right here make the original expression greater than 0. So you can draw like this. Then you continue draw from positive infinity. You draw like this. When the function hits 0, which is the first solution, it goes to 0, right? Then when it passes the first solution, it goes down, right? And then when it hits the second solution, which is 0 again, it goes up, right? Then when it hits the third solution, it goes down again. Then you can draw like this. Next, you put the minus sign right here. Now we see these 3 solutions is actually the same. So the next step you need to do is you squeeze them together into this. You put the number line right here. You put 0. Now you squeeze them together. You only have the negative signs right here. You put the negative sign right here. And positive from 0 right here. You put the positive right here. So it's become like this. After the combination, this diagram became this diagram because 3, 0, you combine as 1, 0 right here. This is the way how you solve this problem. And based on this diagram, you can write a solution set is x less than 0, because you see, anything that right before 0 that make the original function less than 0, which is here. And then the original function, when it hits 0, it becomes 0. When it passes 0, it becomes positive. You can also write a solution set like this. Put 0 right here. And then when x less than 0, we use this bracket. These values, we don't take it. And that's how you solve this problem. Here is another example. X squared greater than 0. We need to solve this inequality. First, we need to solve x squared equals 0. This equivalent to x times x equals 0. This is a product of 2 expressions. So each fraction could be 0. Usually many people will write x equals 0. But when you use this method, you can write like this, x equals 0 or x equals 0. The reason why you use 2 solutions like this, I will explain shortly. The second step, you draw a number line like this. Then you draw 2 solutions in here. The first one is 0 and the second one is 0. Then you choose a number in this number line which is not 0. You can see that in between 0 and 0 here, you cannot choose anything, right? So you don't choose. So you choose from this branch and this branch only. For example, if you choose negative 1 right here and you substitute back to the original expression, you have negative 1 square equal negative 1 times negative 1. You got 1. And this value is positive. Next, you write down minus 1 in here. And keep in mind, minus 1 here is not the solution for this equation. When x take the value minus 1 right here, the original expression is positive. So you put positive sign right here. Then you draw like this. From negative infinity right here, the original expression will be always positive. Then when x hit 0, the original expression x squared hit 0 also. And then when it passes 0, it goes like this. And then when it's hit another solution, which is 0 again, and it's going up like this, then you draw a positive sign right here, We notice in between 0 and 0 there's nothing, right? So we can change this diagram into this diagram. We squeeze two 0 together and it becomes only 1 0 right here. Then you see any value greater than 0 right here, the function is positive. You put the positive sign right here. Any value of x less than 0 right here, that makes the function also positive. You write out a positive right here. So basically it becomes like this. Based on this diagram, you can see x squared is always positive or at least 0 when x take the value at 0 right here. So the solution of this inequality is x less than 0 or x greater than 0. In other words, any value of x different than 0 is the solution. You can also graph the solution on the number line like this. You draw 0 right here, right? Then you see when x greater than 0 or x less than 0, the expression x squared always positive, which means we don't take 0, so we draw like this. This means we take all the value except 0 right here. And that's how you solve this problem. Let's try another one. Let's solve this inequality. We need to write down x squared times x minus 1 squared times x plus 1 equals 0. And we need to solve this equation. We see the power of this expression is 5 because this is 2. And this 2 apply to x and it's become 4. This is 1. So the total power for this expression is 5. It should have 5 solutions. This equivalent to x squared equals 0 or x minus 1 equals 0 or x plus 1 equals 0. For x squared equals 0, you can see that we have two solutions, 0 and 0. They are just duplicate solution, but I want to write down two solutions, x equals 0 or x equals 0. Right here, x minus 1 squared equals 0. We have two solutions here, either x minus 1 equals 0 or x minus 1 equals 0. So x equals 1 or x equals 1. For x plus 1 equals 0, we subtract both sides by 1. We have the left hand side is x and the right hand side is minus 1. So 5 solutions of this equation are minus 1, 0, 0, 1, and 1. Next, we draw a number line like this. Then we put 5 solutions in this number line. Minus 1 right here, 0 right here, and 0 right here, and 1 right here, and 1 right here. And this number line is not a real number line, it's just for you to imagine the 5 solutions here. The next step is you try to pick a number. When you substitute that number back to the original expression, you will find out the value of that expression. For example, 2, right here, you see? When you put 2 into the original expression, you see 2 squared times 2 minus 1 squared times 2 plus 1 is positive. You put the positive sign right here because 2 is here. Remember, 2 is not the solution for this equation. So you can draw like this. The original expression from positive infinity is positive. And then when the variable hit the first solution, which is 1 right here, the expression will hit 0 right here. And then when it passed the first solution, it's go down like this. When it hit the second solution, which is this one, the expression will hit 0 like this. And then when it passed this solution, it's go up like this. Then when the variable hit 0, the expression will hit 0. Then when it passed this solution, the expression will go like this. Then when it hit another solution, 0, the expression will get 0 value. Then when the variable pass 0, the expression go up like this. Then the variable hit the last solution, which is this one. The expression will hit 0. Finally, when the variable pass -1, the expression goes like this. The next step you need to do is you need to draw a positive or the negative side for each range. You see, from negative infinity to -1, you have negative like this. From -1 to 0, you see this shape is above this number line, right? So this is positive. From 0 to 0, it is the same number. You don't write anything from here to here. Similar from 1 to 1, it is a duplicate solution. So you don't write anything from 1 to 1. But from 0 to 1, you see the expression is positive. You write like this. Then you can redraw this diagram into this one. You see, two number 1 goes together at number 1 right here. And then two number 0 goes together and becomes 0 right here. And then this region will disappear right here. And this region from 0 to 0 will disappear. And then you see, -1, you put it down right here. 2 is not a solution. You don't write anything. When x greater than 1 to infinity, you see, you have positive, you write here. From negative infinity to -1, you have minus sign, you put right here. From -1 to 0 right here, -1 to 0, you got positive. And from 0 to 1, 0 to 1, you have positive, you put it here. Finally, you can draw like this. From negative infinity, the expression goes from negative. When it hit -1, one of the solution, right, it becomes 0. And then when it passes -1, it becomes positive. And when the variable hit 0, the expression hit 0 value. And then when it's greater than 0, it becomes positive. When the variable hit 1 again, the expression hit 0. And then when the variable greater than 1, the expression becomes positive. Based on this diagram, you can see when x less than -1, when x less than -1, which is here, the original expression less than 0. And this is the answer for this question. You see, when x equals 0 or -1 or equal 1, these are the solution for this equation. And then in this range, from -1 to 0 and 0 to 1 and 1 to infinity, the expression always positive. So this is the answer for this question. You see the purpose of these two diagrams. You see the second diagram is hard to obtain this immediately. But for the first diagram, you can obtain it easily by solving the first equation. Then you draw like this. The second diagram will help you to see the solution set. Also, you can graph the solution set on the number line like this. You put 1 right here, you put 0 right here, you put -1 right here. And then when x less than -1, you can use this bracket. Then anything that greater than -1, they are not the solution. We don't take these values. And keep in mind, we also don't take -1 as a solution, because -1 will make the original expression equal 0. And that's how you solve this problem. Let's take a look at this problem. The quantity x plus 1 squared times the quantity x minus 1 to the third times x to the fourth times x plus 3 greater than or equal 0. The first step we need to do is we need to solve this equation. X plus 1 squared times x minus 1 to the third times x to the fourth times x plus 3 equals 0. This equation equivalent to x plus 1 square equals 0, or x minus 1 to the third equals 0, or x to the fourth equals 0, or x plus 3 equals 0. For x plus 1 square equals 0, we have two solutions for this equation. The first one is x equal -1, and the second one is x equal -1. They're actually the same, but I want to write them down separately like this. X minus 1 to the third equals 0, we have three solutions: x equal 1, or x equal 1, or x equal 1. X to the fourth equals 0. We have four solutions for this equation: x equals 0, x equals 0, x equals 0, or x equals 0. X plus 3 equals 0. We subtract both sides by 3. We have x on the left hand side and the right hand side 0 minus 3. You get minus 3 right here. So all solutions for this equation is from -3, then -1, -1, then 0, 0, 0, 0, then 1, 1, and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 solutions for this equation. Among these 10 equations, 2 of them are the same, like -1 and -1. 4 of them are the same, and they are 0, and 3 of them are the same, which is 1. But I want to write them separately like this in order to solve this inequality easily. So this is the first step. We solve this equation to find out all the solutions for this equation. The second step, we draw a number line like this. And we write down all the solution in here. From -3, then -1, then -1, then 0, 1, 2, 3, 4, then 3 number ones. 1, 1, and 1. Keep in mind this is just a diagram, it's not a real number line. Now we choose a simple number and we substitute that number into original expression and to see if it's positive or negative. For example, if I choose x equal 2, we see when x equal 2, this is positive. X minus 1 will be positive, and this is positive, and this is also positive. Then the product of all positive numbers will be positive, which means when x equal 2, the expression is positive. Now we draw x equal 2 here, and keep in mind x equal 2 is not the solution for this equation, and we draw like this. For x equal 2, the expression is positive. We put the positive sign here. You know, on the right side right here is positive infinity. It is positive. And then when the variable x hits the first solution, which is this one, the expression hits the value of 0. And then when it passes the first solution, it will go down like this. When it hits the second solution, the expression will hit 0 again. And then the expression will go up like this. When the variable hits the third solution, which is 1, the expression will hit 0 again. When it passes this solution, the expression will go like this. Then x hit 0, the expression hit 0, then it's just like this, up and down, up and down. Just like that. In school, you might be taught to test every variable in each interval here. But when you use this number line, you just only have to test only one variable and draw like this, up and down, around all the solutions, including the duplicate solutions. It's very fast and very easy for you to solve the problem using this method. So the next step is pretty straightforward. Now you see from -infinity to -3, the expression is positive. You put the positive side here. From -3 to -1 is negative. You put the negative side here. And from -1 to -1, it is positive. But because from -1 to -1 is the same solution, you don't write anything in here, right? And from -1 to 0 is negative. You put the negative side right here. And from 0 to 0 is positive, but it is a duplicate solution. We don't write anything in here. And from 0 to 0 right here, we don't write anything. 0 to 0 here, we don't write anything. And from 0 to 1, you see the expression is negative. We put negative sign here. And from 1 to 1 is the same solution. We don't write anything. From 1 to 1 again, the same solution, we don't write anything. And then from 1 to infinity, it is positive because we test number 2 in this interval. From 1 to infinity is already positive. Next, we draw a real number line, which is this one. Now this is the real number line. We put minus 3 in here and minus 1 in here. Now we combine all the duplicate solution at one point. Like minus 1 and minus 1 together, you see? Minus 1 right here. And for number 0, you combine them together. 1, 2, 3, 4. And 3 number 1, you combine together. This is 0. And this is 1. 1, 2, 3. Keep in mind, these are all the solution for this equation. And then minus 1, 0, and 1, they are duplicate solutions. Now we draw number 2 right here. Remember, 2 is not the solution. Based on this diagram, we can redraw in our real number line like this. You see, from 1 to infinity, you get positive sign for that expression right here, right? From 1 back to 0 right here, you have negative sign. From 1 back to 0, you have negative sign. So this one you can draw like this. Negative sign. And you see, from 0 to minus 1, 0 right here, to minus 1 right here, it is negative. You draw like this. From minus 1 to 0, you see, the expression is negative. And from minus 3 to minus 1, minus 3 to minus 1 right here, it is negative. You draw like this. And from minus infinity to minus 3, the expression is positive. So we draw like this. So this is the real number line. You see, when I use this imaginary real number line, you just only test one variable, right? And then you draw up and down around these solutions. But when you use this real number line, you have to test all the variable between each interval, which means if you use this real number line, you have to test one interval, 2, 3, 4, and 5 interval to write out all the solution, right? But with this method, you just use only one interval to write out the solution. Now we see which value of x that make the original expression greater than or equal 0. You can see from negative infinity to minus 3 and from 1 to positive infinity, including all the solutions, minus 3, minus 1, 0, and 1. Therefore, the solution for this problem is x less than or equal minus 3, x equal minus 1, x equals 0, x equal 1 or greater than 1. So x greater than or equal 1. So this is the solution for this example. You can also graph the solutions on the number line. You draw a number line like this. Then you point out all the solutions. Minus 3 right here, minus 1, 0, and 1 right here. Then you see x greater than or equal 1, which means this we use this bracket to include number 1, right? From 1 to positive infinity. Or x equals 0 is a solution. Or x equals negative 1 is another solution. Or x less than or equal minus 3 is the setup solution too. So we draw like this, and including minus 3 here. So anything in between, we don't take these value. These we don't take. And that's how you solve this problem. Imagine if you have to solve a polynomial in factor form with 1,000 or 1,000,000 solutions. Then you just need to try this method. You just have to test only one simple number and then test if the original polynomial positive or negative. Then you draw interval up and down around these all solutions, including these duplicate solutions. Then you can simplify to the real number line. Then you draw a positive or negative intervals like this. If you have any polynomials that don't have the same solution or duplicate solution like this, it's even easier for you to solve the problem. And remember, you don't need to test all the variables between these intervals. You have to test only one variable, and then you can solve the problem. If you have a problem that have a million solutions, so you don't have to test the variable in each interval. If you like this video, please subscribe to my channel for more tutorials. And if you have any question or comments, please leave your comment down below this video. I'll try my best to answer your questions. Thank you for watching. See you in my next videos.